All right, so page 7. So you've got a bag of chocolates, and they differentiate between the colors, right? So 6, 4, 5, and 3. If you add that up, that's 18 total. So remember, for probability, in this unit, you want to constantly be reading for, is it asking me for probability, or is it asking me for odds? Odds are coming your way after this correction here. So we know that this is going to be out of 18. Okay, the probability of a student getting a brown chocolate, so there are 3 brown chocolates, it's just 3 over 18. I want to review the stating as a decimal. Okay, if you want to state that as a decimal, that's what it is. Okay, 0 point, this is a fail-safe. If you round it to 4 decimals like that, you'll be fine. And then you multiply that by 100, it's 16.67%. Is this reduced, 3 over 18? So let's say this is a multiple choice. You would want to go 3 divided by 18, and then I press this button here, the ABC button. So it's 1 over 6. Sorry. Oh, no problem. 1 over 6 is the reduced fraction. So if you want to put that down somewhere here, page 7, 1 over 6. So that's how you reduce it. Getting a blue chocolate is done similarly. There's 4 out of 18. I'm not going to reduce that one. James does not like the blue one, so it's a probability that he's not going to get a blue one. So you've got choices here. It's still going to be out of 18. I know that 4 are blue, so I'm just going to go 18 minus 4, right? So I know that it's 14 out of 18. That is the chance of not getting a blue one. So anything but blue is this one right here. And you should see that these two add up to 100%, right? 18 out of 18, which is 100%. Hannah likes gold or red or gold ones, so you need to grab your red ones and the gold ones and just write it like that. So it's 11 over 18. Say the probability that she will get one she likes, so that's 11 out of 18. That's how you would do that. And then E, if the distribution of chocolates remains the same, how many blue chocolates would you expect in a bag that has way more than our sample? Our sample right now is only 18, so this is a prediction. So we're going to go probability of blue, and we're going to multiply that by the large sample, right? So we know that blue is 4 over 18. We take that and multiply it by 275. So 4 divided by 18, you multiply that by 275, you get 61.11. And that keeps going, actually, I believe, yeah. That keeps going. So you can't have that. So you either say 61 or 62 candies. Okay? Candies expected to be blue. That's like the perfect answer you can give there. If the chocolate remains the same, how about gold or brown? Or is adding in especially probability? I haven't done that yet, so gold or brown, there's 5 gold and 3 brown over 18. That's 8 over 18. Okay, so I'm going to use that probability to predict what's going to happen, what I'm expecting in the greater sample. So that gives you exactly 168 candies. So that's a round number. You're good. All right. Let's go to page 8, deck of cards. Remember, your deck of cards is, what page is that on? Page 3 or something? I'm just going to check real quick. I gave you a little, page 4. I gave you like a business card template on a deck of cards, which I would say if you can shrink that even more, right? Maybe if it could only take up like that much on your study sheet, that'd be great. Okay, so that's like 3 thumbs of mine or something like that. That'd be great. And better yet, memorize your deck of cards if you can. Kind of just do like 52 cards, 4 suits, 13 of each. Half and half are red and black, right? 26, 26, 12 face cards. Like, it's actually not too bad to memorize that. Consider a standard deck of cards. The probability of drawing a 5, there are 4 of them. 4 5s out of 52, that's it. Drawing a face card, you should know that there's 12 out of 52 face cards in a deck. Probably drawing a numbered card, so that's not a face or ace. I should have said that too. Like, you don't want any faces and no aces either. So you got a 52 minus 12 face cards minus 4 ace cards. You're left with 36, right? 36 cards. So that's just 36 out of 52, like that. State the probability of drawing a blackjack card. So there's 2 of them, right? There's 4 jacks, half of them are black, half red. Okay, so it's still out of 52. Probability of drawing a face of clubs. Face of clubs, of that specific suit. There's 13 clubs, and there's only 1 face that is also a club. So this is just 1 over 52, like that. Next, state the probability of getting an ace of diamonds. There's only 1 ace of diamonds, and obviously there's 52 cards still. That doesn't change. I don't know if you saw this. This looks like a typo. Can you make sure you put like a bar on top of it like that? P of not drawing an A. So it's probability of not drawing an 8. Okay, that's basically what this is saying. How many 8s are there? 4, right? So I'm going to go 52 minus the 4 that are 8s. So that's 48 over 52 is my answer there. That's that. So I've done a deck of cards. I'm going to go to page 11, bottom of page 11. The rest I posted the answer key to. Oh, wait, this is new. I just did this for you because you're the first group that gets this insert here. Obviously, even numbers, odd numbers, you should know them. But multiples is what students struggle with. Multiples of 4, right? You start with 4 and then you go up by 4. Multiples of 5, 5, go up by 5. So let's say there's a problem, a question here. What's the probability of rolling a multiple of 3? Write this down. Okay, just so you have one example here. On page 9, what's the probability of rolling a multiple of 3? And we're considering a standard die. So it's not a 12-sided die, it's a 6-sided die. So that's what we're assuming. So how many multiples of 3 do you have from 1 to 6? You have 3, 6. That's it, right? 3 and 6. This is multiples of 3, by the way. Okay, multiples of 3 is 3, 6. So that would be the probability of an M3 would be 2 over 6. Boom, you got it. Probability of even. What's the probability of rolling an even? How many evens are there in a die, on a die? 2, 4, 6. But Mr. Dirksen, you just said 0 is one of them, but a die doesn't have 0, does it? Right? So in that case, this is it. So it would be 3 over 6. So that's how that goes. Quite often the province goes with die or coins or anything like that. So you got to be ready for that. I think the rest, 14 is a deck of cards, 13 is a spinner. So let me go to a spinner so you can at least have one. This is page 13. State the probability that the spinner will land on cat. Well, you should first recognize there's 1, 2, 3, 4, 5 options, right? And only one of them, one section is cat, so that'd just be 1 over 5. Decimal, 1 divided by 5 is 0.2. As a percent, it's 20%. So pretty good. Probably that it will land on gerbil. There are 2 sections, right? 2 of them that are the favorable outcomes and still out of 5. That would be 0.4 or 40% chance of that happening. C, this is going to be a classic. I can guarantee you that that's going to be on a test or a C down the road. If you spun the spinner 650 times, that's a large sample, right? Right, we're extrapolating, we're predicting. How many times will it land on fish? You're making a prediction. You're going to go probability of it landing on fish times the larger sample that we're considering. So what is it? Probability of fish is 1 over 5, and the larger sample is 650. So here we go. That would be, I'm off here, 130 times. And here's where I test your understanding of the concept. How many times would it not land on fish? The probability that the spinner does not land on fish. There's 5, obviously, and so we're going to go 5 minus 1. This is your fish. Right, so it's really 4 over 5. Okay, so you got to be comfortable with 4 or against, like not happening. Okay, how many of you finished 14? Completely done 14? So you're correcting your AC now, okay? What's the probability of drawing a red card? 26 out of 52. That's 1/2, correct? The probability of drawing a red face card. There are 12, right? There's 12 of them, and 6 are red, 6 are black. So this is 6 out of 52. Probability of drawing a black queen card. There are 4 queens, right? 2 of them are black, so that'd be 2 over 52. Probability of drawing a queen of spades. It's very specific to just this one suit here. There's just 1 over 52. Oop, you can see that. A probability of drawing a card that is not a club. So you can think of it this way. There's 52 minus 13 clubs. We know that we're talking about 39 cards that are not in that category. So 39 over 52 is fine. The probability that it's not a red face card, again, there's 52 and there are 6 red faces. Okay, so you end up with 46. So this would be 46 out of 52. Say the probability of drawing a black 9 or a face card. Or is plus in math, right? So we have it out of 52. There are 2 black 9s and there are 12 face cards. This would be 14 out of 52. Okay. So if you were able to follow along, you are having a pretty good grasp on probability and on deck of cards. Okay? All right, I'm going to stop the video here, and we're